Welcome back to the second part of radical expressions. Today we're going to be graphing these expressions. In the first video, we talked about radical expressions and what are they, and now we're going to be talking about their graphs and plotting the x and y coordinates. So what is a radical expression? It's any expression that has a radical. So in this first case, we have a constant being added to a negative radical exponent, radical of x. So you can add or subtract constants. You can have a radical expression where it's just the radical with an index that's not 2. And you can have some sort of algebraic expression inside the radical, such as 2x minus 1. Okay, so if we're talking about a special square root function, f of x equals square root of x, what will that look like? Like anything, we can graph our function, plotting points of x, our inputs, and then getting outputs, and then putting those on the coordinate plane to see what it will look like. So let's go ahead and get started doing that. Now, to make our lives easier, we probably should think what values would be easy to pick for x. Keep in mind, we can choose any values that we want for x for our inputs. So it wouldn't make any sense to choose numbers like 2.3, 7.1, 10.97. Those are tough numbers to take the square root of. We want nice, neat numbers because we just want a general idea of what our graph looks like. So the first number I'm going to pick is 0. I'm going to pick 1. I'm going to pick 4, 9, 16, and so on. I hope you figured out my pattern. The pattern I picked is that these are all perfect squares, okay? So perfect squares are going to help us immensely because it'll make our lives easier when we actually take the square root to find our y. So the first one, we have y equals, or f of x equals, the square root of 0. So in this case, we'd have y equals 0. So there's our first point. Let's go ahead and plot it. 0, 0. Okay, now we have 1. So let's go ahead and take the square root of 1. So y equals the square root. There's my equals. Sorry, in case you don't see it. It's there. Now I know what you're thinking. The square root of 1 is either plus or minus 1. Negative 1 times negative 1 is positive 1. 1 times 1 equals 1. But in this case, we are only going to choose the positive one. Why is that? Well, number one, we're talking about a function. So if we choose negative 1 and positive 1, it won't pass the vertical line test. Okay? And number two, in graphing radicals and radical expressions, whenever you see the radical sign, it's an implied that you're taking the principal root. In this case, the positive root. Okay, so we're only going to be counting the 1 here. So the square root of 1 is 1. I hope you get the idea. We are still going to take the square root of 4, and we get 2. Square root of 9, we get 3. Square root of 16, and we get 4. So we're going to go ahead and plot all these points. So 4, 2 is one of our points. 9, 3 is one of our points. And you can see that it's going to the right faster than it's going up. So 16 and 4. It will look something like this. My pencil will cooperate. Okay, there we go. Notice how, number one, we already decided that it won't go this way. And number two, notice how it won't go to the left at all. Well, that's because we can't take square roots of negative numbers because that would give us imaginary numbers. Next up, we're going to say what our domain is. So our domain is all the possible values of x. So our domain is going to be the left limit is 0. It doesn't go any further than 0. It can be equal to that though. And what's its upper limit? Well, it can go as high as infinity. It can go on forever. So another way to write this is simply x is bigger than 0. That's our domain. What about range? Well, range is the y values, and we already talked about how it can't go into the negative. So again, y is going to be bigger than 0. And then although it's going up slowly, it can go up to infinity. So our y is going to be bigger than 0 for our range also. the cube root function is going to be a little bit different. Again, we're going to choose x values that make this easy for us. Now that we're talking about a cube root and we have an odd index number, we can choose some negative numbers. So what are some negative cube roots that are easy for us to take? Well, we know of negative 8. We can take negative 1, 0, positive 1, and 8. Let's start there. So as we take the cube root of negative 8, we get negative 2. So y equals negative 2. Cube root of negative 1. So negative 1 times negative 1 times negative 1 gives us negative 1. So the cube root of negative 1 is negative 1. Next up, we have 0, which is going to be 0. Then we have positive 1, and then we have positive 2. So notice how it's matching on both sides. So as we go down to negative 8, let me erase this. Negative 8, we're going to get negative 2. Then we go to negative 1, and we get negative 1. We have 0, then we have 1, 1, and then we have 8, comma 2. And we get a graph that looks like, whoops, messed up the bend here. We have a little bend like this. And that is your cube root function. The domain and range is going to be a little bit different here. So if we're talking about the domain, we're talking about the possible values of x. We're talking about left and right. In this case, it's all real numbers. And if we're talking about range, what are we talking about here? We're talking about up and down. In this case, it is also all real numbers. Okay, so the cube root function is drastically different than the square root function. Okay, here we're asked to, for the first example, we're asked to graph each function and give the domain and range. Okay, so we're going to pick values, and we're going to be strategic here, because we're going to try to get perfect square roots that are 3 bigger than we normally would. For example, if we pick 9, we'd get 9 minus 3, and we'd have to take the square root of 6. We don't really want to do that. Okay, so instead of getting 9, we're going to pick something like 12, because then 12 minus 3 equals 9, and then we can take the square root of that. So I'm just thinking ahead to make our lives a little bit easier. So I'm going to pick numbers like 3. I'm going to pick numbers like, what else can I pick? Something 3, 4. I'm going to pick 7. I'm going to pick 12, and now I think it'll be good. Now what happens? So we're going to do y equals square root of 3 minus 3. That's just 0. Y equals square root of 4 minus 3. That's 1. Because that's the square root of 1 equals 1. Y equals the square root of 7 minus 3 equals square root of 4 equals 2. Then we have y equals square root of 12 minus 3. That's square root of 9 equals 3. So now we're ready to graph. We're going to go over here, and we're going to plot our points. 3, 0 is our first point. Then we have 4, 1, 7, 2, 2, 3, 4, 5, 6, 7. And then over here is 12, 4 somewhere. Looks something like this. Okay. Now, how do you know what's the difference between this and the original square root function? If you remember the square root function, it looked like this. So I hope you guys notice that this is just a shift 3 to the right. That's what this indicates here. This is a shift 3 to the right. So our domain should be pretty easy to figure out. Our domain is going to be x is bigger than, greater than, or equal to 3. In the previous example, I said this, and you'll notice that these are both the same thing. They're both saying that x is bigger than 3. Okay, so our range, let me actually style this to red so you can see that's domain. Style red. And our range is going to be y is greater than or equal to 0. Okay, because we're talking about all the values that are bigger than 0. Okay, we have a few more examples here before we're done, but we're almost there. So now we have cube root of x plus 2. So now we just have this. We have the cube root function, which we just graphed, but now we have a plus 2. So we can go ahead and plug in all our normal values that we did for the cube root. We picked -8, we picked -1, we picked 0, 1, and 8. So now we're going to plug this in to our new function. So we have square root of negative, our cube root of -8 is -2 plus 2 equals 0. So in this case, it's 0. Now what I'm doing is I'm kind of doing shorthand. I don't have a lot of space to work here. So I'm kind of doing this in my head, but if you were confused, I would recommend writing this all out on a big piece of paper. So then we have cube root of -1 is -1. We're adding 2, we're going to get 1. Plug in 0, we're going to get 2. Plug in 1, we're going to get 3 this time because we have 1 plus 2 equals 3. And then for this, we're going to have 4. So let's go ahead and plot these points. So -8, 1, 2, 3, 4, 5, 6, 7, 8, -8. Oops, -8 is comma 0. I should have redo that actually. Redo. There it is. -8 comma 0. Then we have -1 comma 1. -1 comma 1. Then we have 0 comma 2. Then we have 1 comma 3. And then 8 comma 4. 2, 3, 4, 5, 6, 7, 8. Okay, whoops, I don't know what I did. What do you notice about this graph? It's almost the exact same thing as the one we had before. The only difference is everything is shifted. How is it shifted? It's shifted up 2 units. That's what this is for. This is our y-intercept. This is 2 up, shifted 2 units up. Okay, so that's what that plus 2 is. So domain and range, how is it affected? It's really not affected much. The domain is still going to be all reals, and the range is still going to be all reals because it's going to go up and down forever, and it's going to go left and right forever. Everything's just shifted up, and that's the only difference. Okay, so we're done with the graphing portion. We're actually going to make a part 3. I wanted to divvy this up into 3 chunkable, workable, easily digestible chunks. So see you next time for part 3.